If given an acid-base reaction, I can identify the Bronsted-Lowry acid, base, conjugate acid, and conjugate base. In the grand scheme of things, this is easy stuff. And you're going to have at least one EOC question on it. So what is a conjugate base? What is a conjugate acid? A conjugate base is what the acid becomes when it gives up the hydrogen ion. I'm sorry, it's reversed. A conjugate acid is what the acid becomes when it gives up a hydrogen ion. No, that's right. What is the conjugate base? What the acid becomes when it gives up the hydrogen ion. And what is the conjugate acid? What the base becomes when it accepts a hydrogen. It's all about playing frisbee. It's all about playing frisbee. Once you throw the frisbee, then you don't have the frisbee, so you can gain the frisbee, so you become a base. Once you catch the frisbee, you now have a frisbee. So the only thing you can do is throw the frisbee. That makes you an acid.
Is the frisbee the
H plus.
Okay.
Gentlemen,
the Arrhenius theory of acids and bases defines an acid as a substance that releases protons in solution, and a base as a substance that releases hydroxide ions in solution. We know that ammonia can act as a base and exhibits alkaline properties, but contains no hydroxide ions. How is this possible? In this lesson, we will learn about the Bronsted-Lowry theory of acids and bases, which fills in the gaps in the Arrhenius theory. You have learned that acids are substances with a pH lower than 7. We can test for acids using universal indicator solution, or paper, which turns red or orange, all depending on the strength of the acid. Blue litmus paper also turns red in the presence of an acid. An example of an acid that you are likely familiar with is hydrochloric acid. Hydrogen chloride dissolves in water to give hydrochloric acid. Hydrogen chloride will dissociate to give a proton and a chloride ion. The proton is not just released, but it is transferred to another substance. For our example, water accepts the proton to form a hydronium ion. A hydronium ion is also known as an oxonium ion. A Bronsted-Lowry acid is a substance that releases or donates protons in solution, in our case, hydrogen chloride. A Bronsted-Lowry base is a substance that accepts protons in solutions, in our case, water. Notice that the definition of a Bronsted-Lowry acid or base is not a function of pH. So an acid-base reaction, according to the Bronsted-Lowry theory, involves the transfer of a proton from one substance to another. In the introduction, we mentioned that ammonia acts as a base even though it does not release hydroxide ions, which is stipulated in the Arrhenius theory. When ammonia dissolves in water, it accepts a proton from water. Notice that this reaction also involves a proton transfer. Can you figure out which substance is acting as an acid in this example? Which is acting as a base? Please pause the lesson.
Okay. Can you? Jeff. Look at NH3. What is closest to looking like NH3 in the product side? NH4. So does NH4 plus have a missing hydrogen plus, or does it have an extra H plus? So that means that NH3 gains an H plus, making it a, and what it becomes on the other side is called a conjugate acid, because now it can give the hydrogen plus away. So if this guy's the base, then this guy must have given the hydrogen ion, making it, and what it becomes on the other side should be something lacking a hydrogen ion.
So are we basically balancing?
No, you're basically identifying who the acid and base are by observing what happens to the hydrogen ion. If you give the hydrogen ion, you're an acid. If you take the hydrogen ion, you're a base.
Lesson to think about this and resume when you are ready. In this example, water acts as a Bronsted-Lowry acid because it releases a proton. Ammonia acts as a Bronsted-Lowry base because it accepts a proton. So a base, according to the Bronsted-Lowry theory, does not need to have a pH greater than 7, or turn red litmus paper blue, or turn universal indicator solution or paper blue or purple. The only requirement is that it is able to accept protons. Have you noticed that water acted as a base in our first example, but as an acid in the second example? Substances that can act as either an acid or a base are amphoteric.
Okay. All right. Let's see. Jeff, you did this last. Pick somebody from this side of the room to do this one. Jackson. Okay, Jackson, look at this carefully. Look at the other side. Which one looks the most like it? Okay, so these guys are a conjugate acid-base pair. All right? What is the difference? Did this one gain an H or does it lose an H to become C2H3O2 negative? Loses the H plus. So if you lose the H plus, you are an, and what you become on the other side is something that can gain the H plus, making you a conjugate base. Conjugate base. All right, if this guy gains an H plus, what is it? You lose an H plus, you are an acid. If you gain an H plus, you are a base. And what does it become on the other side? Something with an extra H plus that it can lose again, because these are reversible reactions. Therefore, it is a conjugate acid. Jackson, look to that side of the room and give me a volunteer. Emily. Any questions about this one? Any questions? Emily. HNO2. Find me something on this side that looks like HNO2. All right. So, did HNO2 gain or lose a hydrogen in order to become NO2 minus? All right, so if it loses it, it must be a, and what it becomes on the other side is a, if this guy is the acid, then that means this guy is, and what does it become on the other side? So the hydrogen goes there, and on this side, the hydrogen can go right straight back. Very good. Wasn't as bad as you thought it was going to be, huh? All right, look at all the folks on this side of the room. Who should volunteer? Who is looking for? Gracie. All right, Gracie. Look at this thing. Which one of these two looks the most like it? That makes a conjugate acid-base pair. In order for NH3 to become NH4, does it lose or gain an H plus? So if it gains an H plus, that makes it the, and what it becomes on the other side? So if this is the base, that means this is the And what does it become on the other side? So on this side, the H is given like this. On this side, the acid is water. But wait a second. Is water a base or an acid? The answer is yes. A bacid. From the examples above, you can tell that water can act as an acid and a base. What do we call these types of molecules that can go both ways? Bacids. Bacids. Amphoteric. This kind of makes sense. Ampho kind of reminds me of amphibians, and amphibians can live on land and on the water, so they can go both ways. And teric, I have no idea what teric means, but I'm sure it means something.
Sounds like Tetris.
Yes, teric sounds like Tetris, except it's missing a T.
And chemistry is a puzzle. Chemistry is a puzzle.
Give another example. Here is another example. HCO3 negative. If it's going to act, oh, Gracie, find somebody on that side. This is a real tough question, so find me somebody good.
I say Sanchez. Sanchez.
Kelsey! Okay, should Kelsey make HCO3 act as an acid or a base? Decide.
Yes.
This isn't hard. Acid! Okay, if HCO3 acts as an acid, what will it look like on the other side? Okay, I need a charge as well because it loses a plus. So if it's already negative and it loses another plus, well, it is negative, but to what magnitude? Does it remain -1? Or does it go to -2 or -3 or what? Okay, did you all see that? If it's negative and it loses an H plus, it not only loses an H, but it loses a plus. So if you're -1 and you lose a plus, you are now -2. All right? What does HOH become on the other side if it gains an H plus? H3O. How about charge? Should there be a charge? If it gains a plus. Well, it was 0 and it gains a plus. Okay, and that is called hydronium ion. All right. Kelsey, you made it act like an acid. Find somebody on this side to make it act like a base. Ben. All right, Ben, in this case, this guy was the acid. In this case, I want you for it to be the base.
So it loses one.
Does that look like it's losing one?
So now it's giving it to the other.
Bases gain electrons.
Okay.
I mean, bases gain H pluses. So what does it become on the other side if you gain an H and a plus and your HCO3 minus?
H2CO4.
Okay,
Or CO2,
you're gaining an H and a plus. You made it gain an H and an O.
So it's just
Or
CO3.
lose an O. What?
So it's just CO3.
Your HCO3 minus. And you're gaining an H and a plus. What does that equal?
H2CO3 plus.
Okay, so you're a minus and a plus.
Okay.
You're adding it together, so what is it?
Negative. No. I've said plus and negative. Neutral. So it's neutral.
Yes.
So when I said H2CO3 You asked me what it was. H2CO3.
All right. And what does HOH become if it loses an H and a plus?
HO minus.
Well, usually it's OH minus, but it's okay. HO minus is close enough for me.
You did a good job.
All right. Good job. What are neutralization reactions? Reactions between strong acids and bases. This is where the acid really, really desperately wants to give an H plus, and the base really, really, really wants to get it. So these reactions are not reversible, because if you're strong, then you end up weak, and then nothing happens after that. So these are not reversible reactions. You're done. You're done. A strong acid and a strong base always results in water and what we call in chemistry a salt. I know you guys call table salt, NaCl, a salt, but that's not the only salt. There are thousands of salts. Basically, anything that can result from an acid-base reaction is called a salt. A salt. To give two examples of neutralization reactions. In this case, you have water and
Salt.
the salt that we're most familiar with. But here's another one.
You have numbers wrong, so I got confused.
This is a strong base because it has a hydroxide. This is a strong acid because there's only 6 strong acids, and this is one of them. I memorized it. And it always produces water and... Mr. Marino, that's not salt. Salt is NaCl. Okay, no, table salt is NaCl. Barium nitrate is produced from an acid-base reaction, so it is a salt as well. What are spectator ions? Spectator ions, well, what are spectators? Do spectators play football games? No, they sit and watch. They may watch cheerleaders. They're spectators. Okay? You watch a soccer game. You're watching a soccer game. Do they do it? Do they at all influence the score? No. Debatable. Yeah, they call it the 12th man, right? When you are playing against a raucous crowd.
Or they could
Streak the field. I guess they could. All right. Ions that don't do anything, they don't change phases, they just look on, are called spectator ions. What is a net ionic equation? The equation who has had all the spectator ions eliminated. Let me give you an example. Write down this example. NaOH dissolved in water equals HCl dissolved in water to yield sodium chloride dissolved in water and water. So what you want to do is systematically go through every entity and ask yourself, did it change phase? If it changed phase, leave it alone. Put it as your final answer. If it does not change phase, Kill it. Delete it. Omit it. Cross it out. Na is aqueous. What is it on the other side? It is a spectator ion. Delete it. Didn't do anything. We are the ions that don't do anything. We just stay home and lie around. And if you ask us to do anything, we'll just tell you, we don't do anything. Spectator ions. All right.
That is scary.
OH, aqueous. OH, liquid. Did it undergo a change? Yes. So you leave it alone, but you have to include the charge. What is the charge on OH?
-1.
Thank you.
Well,
H, aqueous. H, liquid. What is the charge on H? Cl, aqueous. Cl, aqueous. We are the ions that don't do anything. Okay. So this is called a net ionic equation. People like Ben, who gets checks, he gets in his check his gross pay, which he learned the first time not to get excited about. He gets the net pay. That is what he needs to get excited about. The gross pay is what he earned by working. The net pay is how much the government feels that he should keep as an American citizen. So the gross pay is how much he actually earned. The net pay is how much the government feels that he should keep. So, in other words, what's really important? Not how much you earned, what you get to keep. So that is why this is called a net ionic equation. This is called a molecular equation, and it has the taxes that the government feels that Ben does not need, that the government would do better to use by doing all sorts of social programs and paying for the military and paying for the salary of the president and Congress and all that stuff. All right?